So, we have started discussion on phase diagram, but we have not yet defined phases and components properly. So, let us make an attempt to define these terms which are useful in discussion of phase diagram. First, let us define phase. What is a phase? So, a phase is a, it's difficult to define anyway, but we are making an attempt. A chemically homogeneous physically distinct and mechanically separable. This is a traditional definition which is given, mechanically separable part of a system is called a phase. So, this is sort of working definition which we will be using for phase. So, you have already seen or we know that there are three phases of matter. Three phases. So, they can occur in our phase diagram. So, liquid, solid and gas. But from phase diagram perspective, solid is not just one phase, there can be more than one solid. So, we will have solid phases. And what we will mean by solid phases, that different crystal structures will actually be different solid phases. Will be considered different phases. Now, I have already mentioned in the last video that the solid phases in phase diagrams are traditionally shown by Greek letters. So, an example I will like to give here, what I mean by different crystal structure considered as different solid phases. A good example is that of iron. So, iron at room temperature is body centered cubic, and that is considered to be the alpha phase of iron. But at high temperature, it will be cubic close packed, and this is considered to be the gamma phase of iron. We will spend quite some time later on the phases in iron and in iron carbon system, which constitutes steel, which is an important engineering alloy. But for the moment, just to emphasize what we mean by this phrase, that different crystal structure will be considered different phases. So, both BCC iron and CCP iron, both of them are 100% pure iron. So, in terms of chemical composition, they are not different. In terms of solidness or solidity, also they are not different, they are both solids, both crystalline solid, but the crystal structure is different. So, they will be considered different phases from the point of view of phase diagram. Another important terminology in the phase diagram is the component. So, let us define component. So, we will define component as the independent chemical species, and the chemical species can be either a pure element or sometimes it can be compound. So, independent chemical species, element or compound, in terms of which the composition of a system is specified or is or are, depending on whether it is a single component or called components. So, for example, in copper nickel system, the composition will require to give the proportion of copper and nickel. So, in the copper nickel system, the example which we considered, copper nickel system, the components are copper and nickel. So, the diagram which we had was a 2 component diagram. Let us look at some more examples. Sorry, we have already described components. Let us look at some more examples. So, let us consider water. Now, water, of course, you know, is compound of hydrogen and oxygen, but hydrogen and oxygen appear always as one combination, and that is 2 hydrogen atoms to 1 oxygen atom. So, this composition is fixed, you can't vary that. So, in water you can't vary the ratio of hydrogen and oxygen. So, we will consider it as only one single component. So, the component itself is a compound or the molecule compound H2O. So, this becomes the component, and phase is just one phase, which is water. So, the liquid phase. So, you have liquid as your phase. So, it is an example of a single component, single phase system. But suppose you have ice floating in water, you have a water ice combination, then both water and ice are still composed of H2O. So, still you have single component, but now you have 2 phases, liquid plus solid. So, this is an example of a single component, but 2 phase system. Let us consider brine, which you know is solution of sodium chloride in water, but you can change the ratio of sodium chloride to water. So, the composition can be varied with respect to sodium chloride and water. So, that is why you have 2 components, but you can't vary the ratio of sodium to chlorine or hydrogen to oxygen. So, it is not a 4 component system, it is a 2 component system in which you can vary sodium chloride to water. So, it is a 2 component system, but the whole thing is one single solution. So, you have a single liquid phase, which is a liquid solution. Let us take an engineering example, mild steel. In the mild steel, the components are iron and carbon. So, there are two components, because you can vary the percentage of carbon in the alloy. So, iron and carbon are the two components, but phases you will find that in mild steel at room temperature you have two phases. One is the alpha phase and another is a compound Fe3C. So, it is a two component, two phase system. So, you can see that the components and phases can vary. Of course, there are constraints on this variation, which gives us a rule which is called the Gibbs phase rule, which we will have opportunity to discuss later. Gibbs phase rule, relation of number of components number of phases and something called degrees of freedom. We will talk about that later. This we will discuss later. I am just mentioning it here. So, you can have single component single phase system, single component two phase system, two component one phase system, and two component two phase system. So, different kinds of phase diagrams are possible, and there is a nomenclature based on the number of components. The phase diagram, if you have a single component phase diagram, for example, one can talk of phase diagram of water. We are not going to pay much attention. So, then you call such diagram as a unary diagram. So, unary diagram, single component. Suppose you are talking of phase diagram of water only when it is ice, water or vapor as a function of temperature and pressure. So, you will have a unary diagram. The example of copper nickel which I gave you was an example of a binary diagram or a binary phase diagram. Binary, as you know, means two. So, it is a two component. Two components are involved, then we call it a binary diagram. In a ternary diagram, three components will be involved. And of course, you can have higher order phase diagrams, quaternary involving four components and so on, but in this course we will mainly focus on this binary two component diagram. So, our main attention will be focused on two component binary phase diagrams. So, with this we end this video.